coming to my talk. So we will now proceed. My talk is about seeing is not believing. This is all about related to facial liveness detection. So we're trying to fool the sensor used by different identity providers. So let's start a little bit introduction about myself. I am a senior consultant at IOActive, and I'm currently into identity verification and malware development, and I'm holding some of the certificates. You can also visit my blogs, and I go by the name Katin Milo. So our agenda for today are this one, and let's proceed. So identity verification is simply a process commonly employed by financial institutions as part of their Know Your Customer or KYC and their anti-money laundering campaigns. So the goal here is to simply ensure that the users are who they say they are and they are real. And there are different types of identity verification. We have the past knowledge base, where users are required to provide their information known by them, such as their passwords or security answers. We also have the famous one, which is multi-factor authentication, like providing SMS or OTPs through SMS or emails. And then some highly financial institutions or companies also require users to submit their government IDs and biometric samples. So for this talk, we're focusing on facial liveness or facial recognition. So what is facial recognition? It is a process whereby the system is capturing the facial features of a users and compare it to their database. So in a facial recognition, it answers the question whether if this is the right person. In a nutshell, this is how facial recognition works. So the user will present itself or face to the camera. Then the system will capture the facial features of the users and then compare it to their database. So authentication happens whether if there's a match within their database or not. So despite this, of course, attackers are targeting the facial recognition system. And this is commonly called as presentation attack or facial spoofing. So from the name itself, facial spoofing, the attacker simply spoofs or impersonate their victims or real person to bypass the detection system. And it can be done through multiple ways. We have the 2D spoofing, wherein the attacker is printing a photo of their victim, or they're presenting the photo of their victim through mobile phones or monitors, and they're presenting it to the camera or to the sensor. And we also have the video replay attacks, wherein instead of a static image, the attacker is using a pre-recorded video of their victims. And then we also have the sophisticated approach, wherein the attackers were printing a silicone face mask of their targets. So here's an example of what a presentation attacks, the different types of presentation attacks used by attackers. So these presentation attacks has been successful, and millions of dollars worth of money have been stolen by through fraud and imposter scams. So how did they solve these attacks against presentation attack? So identity providers has currently employed what we so-called the facial liveness detection. In a facial liveness, the system or the provider ensures that the biometric sample captured by their sensor or camera comes from a real and live person and not just a fake representation. So in a facial recognition, if facial recognition answers the question if this is the right person, in facial liveness, it answers if this person is live or real. And we have here's a quick example of how facial liveness works. As you can see here, the different types of presentation attacks gets detected as a spoofing. See here, they're using both the 2D and video replay attacks and 2D attacks. So again, all types of presentation attacks have been detected. And we have two types of facial liveness. One is the passive one, and the other one is active liveness detection. In a passive liveness detection, The users are not required to perform some tasks. So it's easier for the users and it's faster and efficient and commonly used by companies that has a large user base. Whereas in the active liveness detection, users are required to follow some instructions which is random. Some of them are random, some of them are not, such as following a dot on the screen or moving their head, tilting their head, or blinking and smiling. So here's an example of what the passive and active liveness looks like. So on the left one, this is the user will just present itself to the camera and AI works to detect whether that person is alive or not. So on the right side, that is active liveness detection, wherein users are required to perform some tasks like closing their eyes or opening it, and they're looking at the screen or turning their head to the left and right. Okay, so despite this type of introducing facial liveness detection, of course, attackers were targeting this one. As you can see in here, here's an example of a photo, a 2D photo or static image that is fed to a 3D mapping software to make it look like a 3D, so that the attacker can tilt or rotate the image, as you can see in here. As you can see in here, the verification process was successful. So another type of attack is here wherein the instructions employed by the active liveness system is not random, it's predetermined. That means an attacker can simply prepare itself doing that kind of instructions. So in here, the users are required to look or to follow the dot, which is not random in nature. So those are the dots that the users need to follow. And there you go. The verification system was pulled. So what's the problem with those approach? So the approach that I presented a while ago is called a video replay attack. And wherein the user's pre-recorded video are presented through to a display or a monitor. This has been effective since last 2023, and it has now been detected, and identity providers are catching up. So, as you can see here, this is the timeline of the different detection employed by to detect presentation attacks. And it has grown significantly. And one of them is what's so-called the recaptured image detection. So from the name itself, identity verifiers can now detect whether the picture presented to the camera or to the sensor is real or just recorded. So what's the problem with the video replay attacks that I presented? Well, of course, we have, through the recaptured image detection, the system can detect the presence of the different monitor features like the reflections, the brightness, pixelations, and we also have the loss of quality since we're just presenting it, the recording. So how can we go about it? How can attackers keep up? So the goal or the objective is, can we trick the sensor to feed directly the pre-recorded video or our source video to the system instead of presenting them to the monitor? And can it be accomplished using a resource-conserving and time-conserving and low-cost approach? So our solution is what's so-called the video injection attack. So in a video injection attack, we're injecting the source video to the system instead of replaying or presenting the pre-recorded video through monitor or the display, like a mobile phone or a monitor. So this one solves the problem with video replay attacks in a sense that the video is high quality and a bit-by-bit replica of the source video. So we're just like, whatever quality the video is, the pre-recorded video that you have, you're presenting it directly to the system. So no loss of quality and so-called. And last 2019 in Black Hat USA, similar a previous research has been demonstrated, but wherein it's used as a hardware modules. So this approach is not quite easy to set up, and some of them are costly or expensive. So how do we deal about this? We'll go software based, and that's through the help of a virtual camera. So from the name itself, a virtual camera is a software base that mimics what a physical camera does. And what's good with virtual camera is that users could select different sources, like whether it's images or scenes or videos, and feed them directly to the target application, whether it's a video conferencing or live streaming or identity verification providers. And the best thing is that they are low cost, and most of them are free and easy to set up. So these are the common virtual camera providers that are very common. And in this presentation, I'm going to demonstrate the three attack methods on three different platforms. We have the desktop, the mobile emulators, and the actual physical mobile device. So the first one is through a desktop. This is the very common scenario wherein the users are using their computers, desktop or laptops, and accessing the identity provider's web application. So instead of using the desktop's physical camera, we're gonna feed a pre-recorded video to the virtual camera software that we're gonna use. So here's an example of a setup that we're gonna use using OBS Studio Virtual Camera. So in this one, we're just gonna choose a video source. So we're gonna feed a local videos that is saved in the computer, and then just loop it and enable hardware encoding, and then start the virtual camera. So what's good here is that the virtual camera allows us to zoom in, zoom out, or move the source image, which is crucial because some identity providers require users to move a little further or move back or move closer to the camera. And here's a sample verification using that type of approach. So here we're just allowing the virtual camera. I'm not sure if you can see it clearly, but there's a green square surrounding the user space, indicating that the verification is successful or the verification is being pulled into thinking that the user is real or not. So another one is through the use of mobile emulators. So mostly we're now relying on mobile phones and we're just for ease of use. And there are cases where we are using the company or the provider's mobile phones to perform the facial verification. So we can trick or we can run their mobile application through an emulator. And then we can simply use the emulator's Mac camera or visual camera to feed our pre-recorded videos. So here's an example. So sample setup wherein, again, we're going to use an image source that is stored, or video source that is stored in the local computer. So that's the pre-recorded video that we're going to use. And then we'll just simply start the virtual camera. All right. And here's an example of the setup that we're going to use using BlueStacks as our emulator. I think everyone is familiar with BlueStacks if you're into games, especially in Android ones. So we'll just use OBS camera as the camera. And here's an example of the sample verification process. So there's a bug in OBS Virtual Studio that hence the square face or the square box is on the side. But what's important is that we can see that the system is fooled into thinking that those pictures are real or a live capture. So what are the problems with emulators? Well, if you're using financial applications like your mobile banks, then most likely they're implementing what we so-called an anti-emulation techniques that prevents their applications from running into in a mobile emulator. Well, technically, as a hacker, we can defeat those anti-emulation techniques. But what if their mobile apps were also implementing what's so-called the anti-tampering or anti-reverse engineering? That's going to be a cat and mouse game because you have to first detect their anti-reverse engineering techniques, and then after that, you're going to defeat the anti-emulation techniques. So worst case scenario, let's say for example, the user's only choice is to use a real physical mobile device. So how are we gonna make a virtual camera using that physical device? So the approach that we're gonna use is what's we so-called is we're gonna make a virtual environment or a virtual space within the phone, and that will act as like an emulator. So, and then what we're going to do is install that target application into that virtual space and use that virtual space virtual camera or mock camera. And here's an example of the setup. So in this case, we're going to use virtual camera live assist. So we'll just go to the settings, use a local video, and then select the video that we wanted. And then save. And then most importantly, we're gonna clone or install our target application. Now that application is running or installed within that virtual space that we created. And here's an example verification. So just like OBS camera, what's the good thing about virtual camera is that we can again move our source video, we can zoom in and zoom out and rotate it. So there's particular bug with this version of the application wherein, as you can see here, there's no detection whether the face is real or not. But once we rotate the video source, the system is now being fooled into thinking that the image or the video source is real. So of course, there's always a pros and a cons into our approaches. And obviously, the pros is that they are easy to set up, because most of the virtual cameras are free and they are low cost and they're readily available and easily accessible, and they are not time consuming and expensive compared to making a hyper realistic mask or going through or installing some hardware modules to feed the video source to the verification system. However, there's a cons always. So there's no assurance that your approach is gonna work. And it might not work in all the platforms, on all of the verification systems. So what's the catch here and what's the threats involved? What are the threats involved? Well, identity theft is now easier to conduct. Imposter scam is easier to conduct because we love posting our videos and selfies through social media, different social media platforms. We have the Reels, Instagram, TikToks, and we love blogging. We love recording ourselves. So I've done this with, I'm not going to show for privacy purposes, but I have done this through a known newscaster in at work. So, yep, identity theft and imposter crime is now easier to conduct. So how are we going to deal this one? First, we're going to have to detect the usage of virtual cameras. Since virtual cameras have their names and we can check the APA functions used by that virtual camera, and virtual cameras have different resolutions supported compared to an actual or physical camera. That's some of the ways that we can detect the virtual cameras. Although we have to beware as well, since some virtual cameras would allow you to change their cameras. Like for example, you can change it into a Logitech, which is an actual physical camera. The next one is we have to protect ourselves or our applications against emulations. And then of course, there are different ways on how we can do this. We can detect some artifacts, the hardware characteristics and different identifiers, the device performance, and the different network environments as well. Last one is that we have to secure and analyze our input video. One good example is through remote image attestation, wherein during the capture process or after the capture process, a private key will sign the hash of that image, And once that image or once that data has been submitted, the companies or the providers publicly will sign those again and make sure that they are compared, or they will be compared and make sure they are matched. If there's a match, then that means the video source feed or submitted to the system is tamper-free and authentic. And of course, there's this AI, which is a cat and mouse game. So we better improve our AI to detect anomalies, which are like the looping videos, deepfakes, and the use of digital filters. This is very crucial if your system is just using passive liveness detection. So, and obviously we also have to employ a layered approach. We should not rely on just one form of identity verification. We can combine facial liveness with a document or ID validation with face matching, wherein, of course, the users will have to, or the system will have to, or the users will have to make sure that the face they're presenting is the same face that's on their ID. And obviously, we have to do some monitoring and logging of the different verification attempts. This is very crucial because, again, pre-recorded videos and the use of virtual cameras does not work reliably and on the first try. And lastly, I believe is we have to better keep on improving. So I've seen a lot of companies that employ active liveness detection. But the problem is that their instructions that the users that need to follow are not random. They can be predetermined, which is not great. And obviously, if your company is very highly sensitive, like banking financial institutions, of course, nothing beats a manual verification, wherein facilitator during the verification process that will require users to do some tasks or present some things.